And now I'd like to introduce a brand new Ruby keyword that is part of the wonderful world of conditionals. Here I have a sample of code, and you'll notice a new keyword on line 4, and that is the else keyword. Basically, what else allows us to do is to create a fork in the road with our conditionals, allowing our code to go down one of two potential paths. Let me explain. So on line 1, we set the variable Homer to the value of 5. Then we begin our conditional on line 2. If Homer is 5, then, line 3, we print the number 1,000,000. For else, meaning if Homer is not 5, that is, if the previous condition has not been met, then we'll execute the code on line 5, which is to print the number 0 to the terminal. And then on line 6, we have our end keyword closing up this conditional. On line 7, we print the contents of the variable Homer. And line 7 occurs no matter what happened in our conditional, since line 7 is outside of the conditional. So you could sort of think of this like a flowchart. We encounter this conditional, this question, is Homer equivalent to 5? If yes, then do this, that is, print 1,000,000. If not, then do that, print the number 0. And this brings us to a new important law involving conditionals. This law is called the blue-orange law. And that's because the blue-orange is really difficult to forget, and you definitely do not want to forget this law. And the blue-orange law of conditionals states that whenever you have a conditional with multiple paths, one and only one of those paths is ever executed, period. So here, for example, we have two paths. We have our yes path, we have our no path. Only one of those paths is going to be executed. We will explore this law in further detail in an upcoming video, but it's important to introduce it to you now. Let's run this code and see what we get in the terminal. As you can see, we get two numbers in the terminal. We get the number 1,000,000 followed by the number 5. Let's use the Peter Jang notation to track the lines of code that get run to see exactly why this is. So the first line of code that gets run is the first line where we set the Homer variable. The next line of code where we begin the conditional gets executed as well. So that's the second line of code to get run. Now, is Homer 5? In this case, it is 5 because we set it to be 5 on line 1. So then the next line of code that gets executed is the code on line 3. The else line gets executed, at which point Ruby understands that the next section should only get triggered if the previous part of the conditional was not triggered. But since we did go down the previous path and run line 3, we get to skip over line 5 so that the next line of code that gets executed is actually line 6. And then finally, line 7 gets run no matter what, since it lives outside of the entire conditional statement. Now let's clear our notation and pick a different case. So we're going to set the Homer variable to be some other number. So let's say it's going to be 7. What happens when we run the code now? Well, before we run the code, let's use the Peter Jang notation to predict what will happen. So the first line of code that gets run is line 1, where we set the Homer variable to be 7. The second line of code to get run is line 2, where we begin our conditional statement. Here it asks, is Homer 5? If Homer is 5, then do line 3. Now Homer is not 5, right? Homer is 7. So we skip over line 3, moving down to the else keyword on line 4. So this is the next line of code to get run. Now since Homer was not 5, we now trigger this alternate, this else path. So line 5 gets run. And then finally, line 6 gets run. And so does line 7. So since these are the lines that get run, we would expect for our code to first print the number 0, as indicated on line 5, and then print the contents of Homer, which is 7. And indeed, that is what we get in the terminal. So the else keyword allows our code to be a lot more versatile, as we can now give our code various choices, that is, a fork in the road, two possible paths to go down based on whatever our conditions are.